or option question 3a, test the convergence of the series summation n is 1 to infinity n plus 1 sine 2n minus 1 pi by 2 divide by n log n plus 1। अब ये सम देख के आपको कैसा लगेगा कि ये सम जैसे बहुत ही कॉम्प्लिकेटेड सम है। क्लियर? जैसे कि ये साइन फंक्शन है, इसमें लॉग फंक्शन है, लेकिन हियर ओनली वन ट्रिक इज यूज्ड। ओके, सो फर्स्ट ऑफ ऑल लेट्स चेक व्हाट इज द वैल्यू ऑफ दिस साइन फंक्शन। ओके, here we are using the property of sine function। Okay, this is sine function। Now first put here n equal to 1। So what we get for n equal to 1, 2 minus 1 pi by 2, so we get sine pi by 2। Now put n equal to 2। So here 2 2s are 4, 4 minus 1 3, so 3 pi by 2, so we get sine 3 pi by 2। Now put n equal to 3, so n equal to 3, 3 2s are 6, 6 minus 1 5 pi by 2, so we get sine 5 pi by 2। Now put n equal to 4, so what we get? We get sine 7 pi by 2, okay, and so on। Now let's check the value of all these sine function। So sine pi by 2 is what? 1। Okay, now just observe the unit circle। On this circle, this is 0, this is pi by 2, here pi, and 3 pi by 2, okay। Again after this one is 2 pi, here 5 pi by 2, 3 pi, 7 pi by 2, again 4 pi, and so on, okay। Now at this point sine 0 is what? 0, sine pi by 2 is what? 1, sine pi is what? 0, sine 3 pi by 2 is what? Minus 1, okay, and so on। So here what is the sine pi by 2? Is 1, what is the sine 3 pi by 2? Is minus 1, sine 5 by 2 is again what? 1, sine 7 pi by 2 is what? Minus 1, okay, and so on। So in general this value is nothing but minus 1 raised to n minus 1, okay। When we put n equal to 1, so we get positive 1, okay। So n is 1, 1 minus 1 0, okay, any number raised to 0 we get one value। Now put n equal to 2, so we get 3 pi by 2, so negative minus 1, okay। So here 2 minus 1 means 1, so minus 1 raised to 1 is minus 1, okay, so we get negative minus 1। Put n equal to 3, so n equal to 3 we get plus 1 value, so here put 3, 3 minus 1 means 2, so minus 1 raised to 2 positive 1, and so on, okay। So first here we find the general value of this trigonometric function, okay, and now put this value in this series। This is our first step, okay। So now put this value in the given series। So now first replace this value by minus 1 raised to n minus 1 in the given series, okay। So now what is the series? Series is n is 1 to infinity n plus 1 upon n into minus 1 raised to n minus 1 upon log n plus 1, okay। So now this one is the series। Now we are interested to find the convergence of this series, okay। So now let's first observe here minus 1 raised to n minus 1 is given, okay। So that's why this series is what? This one is nothing but alternating series, okay। And if alternating series is given, then to find the convergence of alternating series we use Leibniz test. Okay. So now let's first discuss what is the Leibniz test. This is the general form of alternating series. -1 raised to n minus 1 into an. Okay. Now when we say that this alternating series is convergent, for this we need to check two conditions. First condition is mod an plus 1 is less than mod an for all n. क्लियर? मतलब कि हर एक n के लिए क्या होना चाहिए, जो हर एक टर्म है वो प्रीवियस टर्म से क्या होनी चाहिए, लेस. क्लियर? मतलब कि ये क्या है, डिक्रीजिंग सीरीज होनी चाहिए. क्लियर? सेकंड कंडीशन क्या है, लिमिट n टेंस टू इंफिनिटी एब्सोल्यूट ऑफ an इक्वल टू 0. ओके. अगर ये दोनों कंडीशन सेटिस्फाई हो रही है, ओके, देन व्हाट वी कंक्लूड कि ये जो सीरीज है, ये सीरीज क्या है, कन्वर्जेंट. Got it? So now let's check the convergence of this series using Leibniz test. Okay? So now let's discuss the convergence of this series using Leibniz test. Okay? तो हम यहाँ पे क्या करेंगे, फर्स्ट एंड सेकंड कंडीशन चेक करेंगे. Okay? So let's start. For the given series, what is the an? An is equal to here n plus 1 upon n. So now each term is divided by n. So what we get, 1 plus 1 upon n. Okay. Divide by log n plus 1. So this is my an. Now find an plus 1. So an plus 1 is what? 1 plus 1 upon n plus 1 divide by log here n plus 1 plus 1. So what we get? N plus 2. So an and an plus 1 we have. Now let's check whether this quantity is smaller than this quantity or not. Okay. So how to check? Here n equal to 1. Okay. So what we get? a1. तो a1 क्या होगा? 1 plus 1 2. 2 upon log 2. Put n equal to 2. So what we get? a2. a2 is what? 1 plus 1 by 2 upon log 3. Okay. So use the calculator and find this value. Okay, so what we observe? Here we observe that a2 is less than a1. Okay. Same way a3 is less than a2. Okay, and so on. So here in general what we conclude? Here we conclude that mod an plus 1 is less than mod an for all n. Okay. So here first condition of Leibniz test is satisfied. Now let's check the second condition. Second condition, find the limit. Limit n tends to infinity mod an. So here what we have? Limit n tends to infinity. An is what? 1 plus 1 upon n upon log n plus 1. Okay, this is my n. Here all are positive values. Okay, so that's why we can remove the absolute value. Now put the limit. So we get 1 plus 1 upon infinity is 0. And what is the log infinity? Infinity plus 1 is again infinity, and log infinity is what? Infinity. So what we get? 1 upon infinity is 0. Okay, so again second condition of Leibniz test is also satisfied. Okay, so that's why what we conclude here, we can write from Leibniz test, we can say that series n upon n plus 1 upon n minus 1 raised to n minus 1 upon log n plus 1 is convergent. Okay. This is the entire solution for ready reference. ओके तो आप इसमें से पूरा सॉल्यूशन रिफर कर सकते हैं.